Ladies and gentlemen, this is Mambo number 5.
Many of us have hula hooped at least once in our lives, and while some of us are very good at it and some of us are very bad at it, we've probably all at least realized that there is physics in hula hooping. But what forces are involved in hula hooping? And why does the hoop not just fall down? Is it easier to hoop with a heavier hoop or a lighter hoop? Or with a big hoop or a small hoop? And are your hips the easiest place to spin the hoop? There are so many questions to be answered, so let's go to the public and see if they know the answers to these questions.
Sarah, have you ever hula hooped before?
Yes.
Have you ever hula hooped?
Yes.
Perfect. How do you start a hula hooping?
By giving a slight fling of the hoop.
Fling of the hoop.
Yes.
Okay. Cool. And what direction would you say that fling is in?
Counterclockwise.
Okay, so circular,
Yes.
you would say. Awesome. And then how do you start a hula hoop?
You put it around your waist and then you move your hips.
Perfect. In what direction are you moving your hips? Side
Clockwise.
to side? Clockwise? Okay, so in a circular motion.
Yes.
Awesome.
When you stand in the middle of your hoop, you become the axis point, the center of the ring's rotation. And as the axis point, you then become the source of the hoop's movement. When you move your body to propel your hoop around you, you're actually exerting a movement known as torque, which is a turning force.
Since gravity acts on you and there's an upward force pushing on you that doesn't keep you to the floor, why do you think that the hula hoop, while it's rotating, doesn't fall?
Because of the momentum of it going around your body.
Okay, that is part of it. And then will you put your hands on your hips and just like rotate them? Okay, so do you see like how your shoulders each move up and down?
Yes.
Okay, you can stop rotating if you want. So just like the ground pushes up on your feet and keeps you from falling through the floor, your hips actually provide an upward force that keeps the hula hoop from falling due to gravity.
I knew that.
Okay, good, good, perfect. Where do you feel the force of the hula hoop acting on you, and where do you think it acts?
I feel the hula hoop on my hips until it falls, then it's on the rest of my body where it touches.
Okay, so you would say that the hula hoop exerts a force on you, correct?
Yes.
Okay. And then which direction do you think that force is pointing?
Down, like inward, actually.
Yes, okay, and then that's correct, and that's actually called centripetal force, and centripetal force is just like circular motion, and so you feel a force going inward on you because of that, but your body force is also equal and opposite to where the hoop contacts you. So whenever the hula hoop is making contact with your waist, your body actually exerts an equal and opposite force on it as well, which is why it doesn't just saw you in half.
Torque is necessary to maintain the centripetal force which keeps the hoop spinning along its axis. And yes, we are talking about centripetal force, not centrifugal force, which is a common misconception. Centripetal force is a force that makes a body, such as a hoop, follow a curved path. It is always directed orthogonal to the velocity of the body towards the instantaneous center of curvature of the path. The amount of force that is needed depends on a couple of things. One being the size and weight of the hoop itself, and how it relates to the size of your waist.
Oh man, I haven't hula hooped in so long. That one? It's really lightweight.
Yep.
And it's not. Yeah, it's hard. It keeps like flying around. That probably can
Okay, so like you said, that one's really light. So
Yes.
do you think that it's easier to use a heavier or a lighter hula hoop?
probably heavier. Yeah, I would think heavier.
Okay, and then why do you guys think that?
it would stay up and it's easier to like control it, I feel like.
Yeah. Okay, and then have either of you like had physics at all?
Yes.
Yeah.
Okay, so do you know how to explain that in like physics terms?
Centripetal motion? Let's go with that.
Yeah. Okay, so that is one of the forces that's happening. So centripetal force is actually what's acting on your body as the hula hoop moves around you. But it's easier to use the heavier hula hoop because even though it does use like a larger force to keep it up or to start it, once it's in like a consistent motion, it's easier to keep it up. And that's because the rotational inertia helps to support it, and then it requires more torque actually to keep the lighter hoop up. Basically a couple different kind of hula hoop. That one has beads in it, that one's empty, and then this one's actually heavier. But if you guys want to try those out first, and then why don't you tell us after you try a couple of them out which ones are easier to use. Okay. Gotten to try out a couple different ones. Do you think it's easier to use a lighter or a heavier hula hoop?
For me, the heavier one helps me.
Yeah.
The heavier ones.
Okay, and then why do you guys think that?
I think I can like support it. I don't know better.
Yeah.
If it's light, it just kind of goes all over the place and like it just goes down.
Okay, and that is definitely part of the answer. The full answer to that is that when you, even though it does actually require a larger force to start the big hula hoop, once you get that started in a constant motion or like a consistent motion, it's easier to keep it up, and that's just because of rotational inertia, which is like a inertia that happens by something moving in a circular motion. Then that actually helps to support the hula hoop, and rotational inertia is related to torque, and so when you use a lighter hula hoop, it requires more torque, which is the force you're applying to actually keep that lighter hula hoop up. So Elise, what do you think that it's easier to use, a smaller or a bigger hula hoop?
I almost feel like smaller would be easier because it's smaller.
Okay, and so what we determined for this was actually for an average size adult, which like in this case you are, it's easier to use the bigger hula hoop only because the smaller hula hoop spins much faster. So when you use it with like a child, that radius proportion to the child's waist, they can move their hips in a manner that's like fast enough, in a small enough circle to keep that hoop up. But it's actually easier for an adult to use the bigger hula hoop just because it's more proportional. And with the smaller hoop, you can't get enough momentum and angular inertia.
Does it require more force to spin a hula hoop around your arm, around your leg, or around your waist?
Your leg.
See what it's like to get a hula hoop going on your arm.
Yeah.
Yeah. Okay, awesome. And then you guys can stop if you want. So do you think it's easier to spin the hula hoop on your arm or on your waist? Okay, and then did you think it was easier to start it on your arm or on your waist?
I don't know, I had a bigger one.
Yeah, so definitely it's going to be easier on the arm to spin the smaller one, but if you both would use the larger one, you're definitely correct in that it's going to be easier to keep it up and going on your arm.